Then after lines we come to circles. So circles are nothing but we will have the equation quadratic in x and quadratic in y. That is, we will have x square and y square, and the coefficient of x square and y square will be same. In first circle, the center is origin and the radius is a. So the equation of circle will be x square plus y square equal to a square. So radius is a, so with this point will be a, this point will be a, this point will be minus a, this point will be also minus a. So our circle will be something like this. This point is minus a, this point is a, this length will be a, which is the radius. So this is the equation of circle whose center is origin. Then we have the center on positive x-axis. So that circle will be something like this. This circle passes through origin also. So this equation will remain same, that is x square plus y square will remain same. Only here we will add one more term, that is minus 2ax equal to 0, where a is radius. Okay, so our center will be here, that is a comma 0, and this will be our a and this will be our a, that is radius. This equation, this is a circle, here we have x, so this circle is on positive x-axis. This, when we put x equal to 0, y equal to 0, we will get this point, that is this circle passes through origin. To find this point, we put y equal to 0, we will get this point as 2a comma 0. Okay, so this is our equation of circle on positive x-axis. Similarly, we can have the circle on positive side of the y-axis. So equation of that circle will be exactly similar to this, that is x square plus y square minus 2. Here the circle is on positive x-axis, so we have x. Here the circle is on positive y-axis, so here we will have y equal to 0. Okay, similarly here we will have the point 0 comma a, and this point will be 0 comma 2a. This will be our radius a. So this is the equation of circle on positive y-axis. So these are the circle equation of circle in Cartesian coordinate. We also have the equation of circle in polar coordinate. After doing substitution, that is x equal to r cos theta and y equal to r sin theta, when we do this substitution, we will get equation of circle as r equal to a in polar coordinate. Okay, so r equal to a is an equation of circle in polar form for this circle. Similarly, when we put x equal to r cos theta, we put r equal to sin theta in r sin theta in this equation, we will get r equal to 2a cos theta. So this is the equation of circle in polar coordinate for this circle. Similarly, we will get r equal to 2a sin theta. Okay, so this will be 2a sin theta. So this will be the equation of circle in polar coordinate for this. Okay, so these are the circles in polar coordinate as well as in Cartesian coordinate. After circles, we have the parabola. So the parabolas will have the equation, one variable will be quadratic and one variable will be linear. So whenever we have one variable quadratic and one variable is in linear, then that will be definitely parabola. So first we have parabola, this parabola, very common parabola. So this parabola is nothing but y square equal to 4ax. This is our x-axis, this is our y-axis. So now y square equal to 4ax. So this equation is quadratic in y and linear in x. So whenever we have this curve, these curves will always be symmetric about x-axis because this equation is linear in x. So this curve will be symmetric about x-axis. So this is symmetric about x-axis. So here we have plus 4ax. So this curve is opening towards positive side of the x-axis. Similarly, when the equation is y square equal to minus 4ax, this curve is symmetric about x-axis. But here we have minus 4ax. Therefore, this curve will open towards negative side of the x-axis. So this curve is something like this. So this curve is y square equal to minus 4ax. Why these two curves are passing through origin? When we put y equal to 0, we get x equal to 0. So y equal to 0, x equal to 0 is one point of intersection. So this point of intersection of a curve and the coordinate axis. So this curve will always pass through origin. Similarly, here we have quadratic in y and linear in x. Then we will have the quadratic in x and linear in y. So whenever we have quadratic in x and linear in y, since it is linear in y, this curve will be symmetric about y-axis. Here we have plus 4ay, so this curve will open towards positive side of y-axis. So this is our curve x square equal to 4ay. Similarly, we can have the curve x square equal to minus 4ay. Since this equation is symmetric about y-axis, so this is our y-axis and this is our x-axis. This curve has minus 4ay, so with y we have minus, so this curve will open towards negative side of the y-axis. So this is the curve x square equal to minus 4ay. So these are the parabolas.